Hey everybody, this is going to be a low effort video on some low effort GD&T AI Slop from LinkedIn. All right, so let's jump into reviewing this poster that was made. So the purpose of this video is not to make fun of anyone who's learning GD&T. We all start somewhere. The purpose of this video is to demonstrate why it's important to learn from a professional or at least a reputable source, because AI makes tons of mistakes and we'll go over some of them here. So let's start with the title, GD&T Made Easy, Geometric Dimensioning and Tolerancing. GD&T is a language used on engineering drawings to communicate design intent clearly. That's great. Love it. What is GD&T? Controls the variation in size, form, orientation, location, and runout of features. Doesn't really control them as much as it tells the machinist, this is maybe how tight this tolerance needs to be, and then it gives, more importantly, to a certain extent, the inspection team, it gives them the knowledge of what's important to pass apart or fail apart. So I'm going to give this an X. Improves fit, function, and performance of parts. Again, doesn't really improve the part as much as it communicates the intent of the part to the manufacturing team and the inspection team. So again, I'm going to give that an X. Feature control frame, and then here's an example. It's position control frame. Sure, that's fine. I don't know. It's not terribly valuable, though maybe they should have referenced this later on. So let's get into the form controls or shape controls. I don't like this title. Straightness, symbol looks good. Name looks good. Controls the deviation of a line element from a straight line. It's not really the definition. Is that the meaning? No, I don't like it. And then this image is unfortunately one of the better ones. It's pretty close to being correct, though. Typically you'll have an arrow pointing at something, or a dot because it's pointing at a surface, and because this is an isometric view and straightness is orientation dependent, we would need to have something indicating which direction that line tolerance applies in. So I'm going to give this an X. Roundness or circularity, these are flipped. Maybe you could put roundness in brackets, but I would scrap roundness. Whoops. The symbol actually does look good. Name is incorrect. Controls the roundness of a feature. What does it mean for something to be round? Not a great description. This is an okay-ish image. Still going to give it an X, though. Cylindricity. This is not what the feature control symbol looks like. The name is good. Controls the cylindricity of a feature. Okay, again, what does that mean? And then we've got a cylindricity feature control where instead of a cylindricity symbol, we've got a diameter symbol. And for those of you who don't know, because if you've been learning off this chart, you're not going to know, cylindricity looks like that. So that's incorrect. Profile of a line. This doesn't belong in a form control section. In the standard, profile gets its own section. So these two don't belong here, but let's continue. Symbol looks good. Profile of a line, sure. Controls the profile of a line element. Okay. It's kind of just not very, it doesn't tell you much. And then some crazy shape here. The leader doesn't quite make it over. But the feature control frame looks good. It just doesn't seem to be applying to anything. Profile of a surface. Again, looks okay. It controls the profile of a surface element. It should control the entire surface that it's applied to. So I wouldn't say it controls the profile of a surface element. I don't like that description. And then we get the wrong symbol here. They got it right over here and then got it wrong over here. So this is no good. Orientation control, direction controls. It's not a direction control, so we'll give that an X. The parallelism symbol looks good. The name looks good. Controls the parallelism between surfaces or axes. I would say it controls the parallelism between a surface or an axis to a datum reference. So this gets an X, and then there's a couple of parts that are vaguely parallel to each other. That's kind of useless. And then this is important. Parallelism needs a datum reference. So we need to have a datum here. You can't have something parallel to nothing. You know what I mean? It needs to be parallel to something. Perpendicularity, again, symbol looks good, name looks good, controls 90-degree orientation between surfaces or axes to a datum. Big X. And then again, needs a datum reference. Big X. Angularity, looks good, looks good. Controls angular orientation between surfaces or axes to a datum. Needs a datum reference. Okay, so orientation control wasn't great. Let's get on to location controls. Or position controls in brackets. Position control is a type of location control, so it's weird that they named the entire section or put the section in brackets. Though, to be fair, in the 2018 version, the other two types of locations were axed, so it is just position. I'll give them a half mark on that one. Symbol looks good. Position looks good. Controls the exact location of a feature. Controls a feature's position within a tolerance zone. So don't like that. Okay, this is maybe some of you were expecting me to complain about this. You can have a positional control without a datum, but it must be part of a pattern. You can't have a single hole, which it looks like this is a single hole, with a datumless position tolerance. So this gets an X. Concentricity, symbol looks good, name looks good, controls the concentricity of cylindrical features. What does it mean for something to be concentric? Nobody knows anymore because it's out of the standard in the 2018 version. And then again, concentricity requires a datum. Symmetry, symbol looks good, name looks good, controls the symmetry of a feature about a center plane. I'd have to look up the definition, but I believe it is controls the symmetry of a feature about a datum, not a center plane necessarily. Bad. And then they get the symbol wrong here. And once again, requires a datum reference frame. Both these images are not very good either. Okay, runout controls, rotational controls. In the 2018 version of the standard, they explicitly remove any reference to, maybe they don't, but they try and remove the references to the way that you would measure it. In the 2009 and earlier, they talk about rotating a part with a dial indicator, and then in the 2018 version, they remove that reference. So rotation control, I don't think that should be there. Symbol looks good. Circular runout looks good. Controls variation in rotation about an axis. Circular. Okay, what does it mean? Circular versus total. Well, this just means one element. So X. And then this is the craziest drawing I've ever seen. I'm assuming this is supposed to be a dial indicator. There's no datum. We need a datum. It's a crazy image. Total runout. This is not the correct symbol. Scratch that out and it looks pretty okay. So we get this next. Total runout. Whoops. Total runout, actually, the name is good. Controls total variation in rotation. Again, no good. This is the closest, I think, to... Oh, no, the circular or concentricity actually had a pretty good arrow. But I think this is one of the better looking applications of the datum reference frame, or sorry, the feature control frame. But we do need a datum, so this gets an X. Okay, we're almost done. Datums, reference features. Primary, most stable. Primary typically controls the most degrees of freedom. I don't know if I would call it most stable. It's a bit of a weird thing. X. Secondary datum and tertiary datum, they don't really have any descriptions, so it's hard to get mad at that. Datum feature A looks like it's pointing at the bottom. Datum feature B is this surface. Datum feature C looks like the back surface. Okay, whatever. Kind of a weird drawing. I'll give it an X. Datum establishes a coordinate system to locate and orient features. it gives you a reference to measure from, I think is a better description. Okay, and then common data modifiers. And then we don't talk about data modifiers, we talk about material modifiers. So this gets an X. M. Okay, let's assume this was material modifiers, this section. M looks good, maximum material condition. MMC, feature contains maximum material, that's not bad. LMC, least material condition, feature contains minimum material, sure. RFS, regardless of feature size, tolerance applied regardless of feature size. You might think that's good, but R is actually not the symbol for RFS. It used to be S, and then is now actually just, there is no symbol applied to it. So this is no good, this is no good, and this is no good, but we do jump back to talking about datums. And then key takeaways, GD&T ensures function, fit, and performance. Yeah, kind of ish. I don't know. Reduces ambiguity in communication. I do agree if everyone's properly trained. It controls the function, not just the dimension. Tells you what the function of the part is. Without GD&T, dimensions are just numbers. I don't know if I would agree with that. GD&T just explains the numbers better. And then remember follow, R, form, shape, orientation, direction, location, L, and then O is run out. And then we skip profile. Don't remember follow R. This gets a big X. So overall, this gets a 0 out of 10.